Hi class, we continue our study in chapter 12 talking about circles and other conic sections by moving into section 12.3, which talks about inscribed angles. So we have two objectives in this section. First is we want to find the measure of an inscribed angle. The second is we want to find the measure of an angle formed by a tangent and a chord. All right, so first off, what is an inscribed angle? So an angle whose vertex is on a circle and whose sides are chords of a circle is what we call an inscribed angle. So like angle C here is an inscribed angle because its sides are chords that emanate from this point right here. And this right here is what we call the intercepted arc. So this inside here is the inscribed angle. So an arc with endpoints on the side of this inscribed angle and whose other points are the interior of the angle, as I said, is that intercepted arc. So in the diagram, all right, the inscribed angle is C, and it intercepts arc AB here. So remember, this doesn't come up, so it's arc AB. So that's signed arc AB. All right, so a couple theorems. So the measure of an inscribed angle is half the measure of the intercepted arc. So the measure of angle B is 1/2 the measure of arc AC. All right, so let's do an example. So let's say find the measure of angle ABD. Well, I look here and I see that its arc right here of this intercepted arc here is 124 degrees. So the measure of angle ABD here is 1/2 the measure of arc AD, or 1/2 the measure of 124 degrees, or just 62 degrees. Let's do another one. Let's find the measure of arc EFG. So I want to find the measure of this arc. All right, well, what I see here, right, is that it's the arc for the inscribed angle H right here, which is 90 degrees because its sides form this arc here, right? So we're given that the measure of angle H is 90 degrees. So measure of angle H is 1/2 the measure of arc EFG. So put 90 degrees over here. Basically, you have to multiply both sides by 2. And the measure of this arc here is EFG, right? I'm going to go back a little, but you see really what I'm using is to get this intercepted arc here. I'm always showing the endpoints of the inscribed, or the vertices here, if you will, of the inscribed angle. All right, let's do another one. Let's find the measure of angle T here and the measure of angle R here. Well, if you look, you can see that the measure of angle T, all right, this has intercepted arc SQ, and the measure of angle R also has intercepted arc SQ. So the measure of angle T is equal to the measure of angle R because it has the same intercepted arc, and that's equal to 1/2 the measure of arc SQ, well, which is 1/2 of 66 degrees. So the measure of both T and R is 33 degrees. Let's do another one. So what are the values of A and B here? All right. Well, what I can see here, since the measure of the inscribed angle PQT here is 60 degrees, right? Notice that PQT, right, and the arc for PQT is basically A, arc PT here. We can find the value of A, right? Well, I see that PQT has a measure of angle 60, so 60 is equal to 1/2, and PT is A, so A must be 120 degrees. All right, well, since we know the value of A, we can use that to help us find the value of B here. So start with the inscribed angle PRS. Well, the measure of angle PRS is equal to 1/2 the measure of PS. Well, I can see that PS is equal to PT plus TS, which is 120 plus that 30 degrees. So that's 150, and 1/2 of that is 75. So the measure of this angle here must be 75 degrees. All right, a couple corollaries to this theorem. So first one, two inscribed angles that intercept the same arc are congruent. Like we see here, measure of angle A, the measure of angle B, they intercept the same arc, so these must be congruent. And finally, an angle inscribed in a semicircle is a right angle, like this, right here. So any angle inscribed in a semicircle like this is a right angle, right? So that what I'm saying here is that its vertices here form a 180-degree arc. It must be a right angle. And the opposite angles of a quadrilateral inscribed in a circle are supplementary, right? So basically this angle plus this angle is 180 degrees, and this angle plus this angle is 180 degrees. All right, so let's find the measure of each numbered angle. So I want to find the measure of this angle 1 here. Well, angle 1 is inscribed by a semicircle. You can see it's half. So by corollary 2, the measure of this is a right angle. It must be 90 degrees. What is the measure of this numbered angle 2 here, like this? Well, notice that the measure of angle 2, all right, its arc is right here. And then this other angle here has the same arc. So measure of angle 2 and 38 degrees intercept the same arc. So by the first corollary, they're congruent. And the measure of angle 2 then must also be 38 degrees. All right, another theorem. So the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So what we have here is I want to find the measure of angle C, right? This right here. So this is the tangent line and its chord. So the measure of angle C here is 1/2 of this arc, the measure of arc BDC. The flip side is true as well, right? The measure of angle C here is 1/2 the measure of this arc, BDC. All right, so in the diagram, line SR is tangent to the circle at Q. So if we know the measure of arc, where is it? PMQ, so PMQ here, from here to here is 212 degrees. What is the measure of angle 1 here? All right, so the first thing I'm going to do is I'm going to have to find the measure of angle 2. Well, the measure of angle 2 from the previous theorem there is 1/2 the measure of PMQ. So it's 1/2 of 212 degrees. So it's 106 degrees. Well, then, all right, recall that angles that form a linear pair are supplementary. So angle 1 and angle 2 are supplementary here. So if I know that the measure of angle 2 is 106 degrees, subtract it over from 180, the measure of angle 1 just must be 74 degrees.